2/3. 52 was straightforward, a lot of log properties. All right, 52, page 193. X times the square root of x squared plus 1 over x plus 1 to the 2/3. So this says to find dy dx using logarithmic differentiation. So I'm going to log both sides. So I have the log of y equals the log of all of this. Oh, I know, it's so much. I'll write it. I do expect y'all to write it so much. I'm gonna expand the right side here. So I have log of y equals, I'm gonna first split it up with subtraction. That was the last one. Y'all okay there? I'm gonna split this one up because I'm multiplying, and if I'm multiplying, I can split that up with addition. Basically, you want to do everything you can. Right, you want to expand it completely. Now I'm going to do exponents. This is all algebra 2. Would it confuse you if I do this? Yay. For the square root. Now, how about if I do?
The problem is that, like, Dan is just,
Dylan. Okay. Now I am ready to derive, and I am going to do the derivative on both sides. So the derivative of the log of y is 1 over y dy dx. And then the log of x is 1 over x. The log of this is 1/2 times, oh my gosh, get it together, man. But I have to do dx, so I've got to do 2x here, yes? Minus 2/3, 1 over x plus 1, and dx here is just 1. So now I'm ready to clean it up a little bit and get dy dx by itself. So I have 1 over y, dy dx. I have 1 over x plus, these 2's go, so I have x over x squared plus 1 minus 2 over, now it's just going to be a matter of a lot of writing because, we'll multiply both sides by y. And now I'm going to replace y with what y was originally. And I'm not going to do anything with it past that. But you do need to replace it because I found the I can't say that the derivative of y with respect to x is with a y in it, because then I haven't found the true derivative. All right, so I have x over x squared plus 1 minus 2 over 50 times x plus 1. And then what was y originally? We haven't used our brain yet. There's the derivative. There's derivative. I didn't do the power rule on the last one. I did the log property that brought the exponent around to the front.
I didn't realize.
I hadn't taken the derivative at that point. Not the x, but that 2. Yeah, because this would essentially be over 1, and 2 over 2 is 1. So.
Right. I just thought because that one half is multiplied by 1 over x squared plus 1. I guess it makes sense because the 2x is multiplied by 2. Pretty cool.
So for all this, you want to
All right. All right, guys, I don't mind working them, but I'm working them for you, remember. I don't need them. 55. I do enjoy doing them. Find an equation for a line that is tangent to the graph of y equals e to the x. It just means derivative. And goes through the origin. So the slope. Right? So now write the equation of the tan line. Write the equation of a line that goes through this point with this slope. Y minus 0 equals slope times x minus 0. We didn't have to. Yeah. Right? What did I do wrong? What did you do? Find an equation for a line that is tangent to the graph y equals e to the x and goes through the origin.
That's the one.
That's the one. What did I see? Yeah, they did like y.
What is?
They did y2 minus y1. Oh, wait. No?
You can do like 0.
This point is not on this graph. Zero, 0 is not on the graph of e to the x. 0, 1 is on the graph of e to the x. Okay, let me think about it in a minute. The only way
I got a bump there, she's 50 for comic books.
my line, if my line has to go through the origin, then it has to include this point. So my y coordinate, the problem is x times e to the x.
Why do you do that?
The slope would be e to the x. It's got to be e to the x. If it goes through the origin, we'll come back to that before we get bogged down on that. 59 says the amount of radioactive plutonium is 20 times 1/2 to the t over 40. At what rate Is the plutonium decaying when T equals 2 days? Answer in appropriate units. I gotta do the derivative if I want the rate, right? Well, let's do it. Right, the thing that clued me into derivative was because it asked for the rate. So the derivative here would be 20 times. Now let's do this. This is a to the x, right? So what's the derivative of a to the x? Get your derivative sheet.
Oh, log of A.
Dang it. So I'm going to have 1/2 to t over 40 times the natural log of 1/2 times dx. This is my x. What's the derivative of that? What's the derivative of t over 40? 1 over 40. Yes?
That's always a formula for the derivative of a or something.
Okay, so number 59 gave you this formula in the problem, which is typical calculus. They'll give you this convoluted formula, and then you'll have to know like what to do with it. Oh, yes, that's on your derivative sheet. Yes. All right, so what I'm going to do, I'm going to combine what I can, but I would say this becomes a calculator. Well, no, yeah, because it asks you at 2 days.
What would you do?
But what I'm saying is they said at t equals 2 days, I would have to pull the 2 in here for the t, and then I would use my calculator, and it's probably going to be some random decimal is what I'm guessing. Why did I not do the derivative of what? Think about it being a coefficient in front. Theoretically, you could, Lizzie, and that's a good point. Did y'all hear what Lizzie said? Because this is a calculator problem. You could definitely do deriv on here. It's a great point. I would definitely, though, show that you know that you have to take the derivative. All right, so when you plug in 2 for this, when you plug in 2 here, fellas, when you plug in 2 here, you should get approximately 0.098. It said the rate it's decaying when t equals 2 days. And so then you have to remember, you don't get your answer point if you don't put your units. Rate. No, what's the rate? Something per day. What? Not decaying per day. What? Look at the problem. Let me read. The amount A in grams of radioactive plutonium. Grams per day. Y'all are getting me so excited. I'm throwing my pen. Shut up, man. Grams per day. Yeah.
They're low-key very low.
Yes. All right, number 60. Shh. Guys, we got to get through this math. Number 60, for any positive constant k, the derivative, did you get that? The derivative of the natural log of kx is 1 over x. Prove this fact. As long as k is... Okay, but it does. It does something in the... If I took the derivative of this, it would be kx, but then I got to do chain rule. If you take the derivative of log of kx, and you know that k is a constant, k is just a number, the derivative of a log is 1 over whatever this is.
Oh, yeah.
Remember, it's 1 over blah times the derivative of blah. So 1 over kx times, and then the derivative will just be k, because so then it's gone. Okay, so that proves it using the chain rule. If I use properties of logarithms and differentiating, then what? It says, part A says by using the chain rule. Chain. I know my pen's getting. And then by using log properties, well, now if I do the derivative here of all of this, well, the derivative of a constant is derivative of x is 1 over x, so it would just be 1 over x. So either way you look at it, it comes back full circle. Yeah. Oh my goodness, y'all are killing me.
Take the next lesson and take a brain break at 4.
There's not a lesson. We're reviewing for our test on Tuesday. 61. Y'all are getting me to do all of these. F of x is 2 to the x. It asked you first to find the derivative. Oh, you said part B. Part B says use the definition of the derivative to write. To find the derivative here, remember a to the x, the derivative of a to the x is a to the x times the natural log of a.
So it's kind of like chain rule, but just with a natural log, right?
What?
Well, you don't take the derivative.
Well, I was just saying.
Of a. So just set it there. Anyway.
So the derivative at 0 would be 2 to the 0 times the log of 2, which would be 1 times the log of 2, which would be the log of 2. If you do the derivative of that. No. No. All right, use the definition of a derivative to write f prime of 0 as a limit. So here's probably where you got confused because you didn't remember the definition of a derivative. So the limit as h goes to 0 of f of x what? Plus h minus f of x all over h.
Oh my, I forgot about that. That's good. I love you. That's the particle motion.
It says use the definition to write it at 0 as a limit. So this is when x is 0. This is when x is 0 because it says f prime of 0. And so I get the limit as h goes to 0. Well, f of 0 plus h is f of h, right? So, and remember, f of x is 2 to the x. So I've got 2 to the h minus, now what's f of 0?
Where did you get 0 is 1. Like, where in the world is 1?
What is f of 0 plus h?
Okay. But because the h is the x. How's it?
Whatever's in parentheses is what you're replacing. That's the answer. That's by definition. It didn't ask me to do anything else with it. It says use the definition to write. Now, part C says deduce the exact value of that. What am I going to do? Any ideas?
What's the exact value of that? So are we looking for a point? Well, you just can't plug in 0.
Can't plug in. Yeah, we do. What are we going to do?
We're probably gonna like two separate fractions. You can make it log.
I'm gonna have to come in with logs for something. How?
Yeah, I'm just thinking it's not probably gonna work out. Log of 2h minus log 1 minus log of h.
Well, I'm thinking of the knowledge that you have.
Ellen, shut up. I don't want to hear you talk right now. No, just be quiet. No, I want to do that. Close your mouth.
I wanted you to say, since this is by definition the same thing as the same thing as this, then they set them equal to each other and work from there. You can't do that. You can't use.
No, they didn't invent it. They said it equal enough.
No, let's stop there. I don't agree with what they're trying to get you to on that. All right, let's go on to the review. Can you what? Yes. 34 asks us to find all values for which the function is differentiable. So where might I not be differentiable? Page 196. A cos, what else? Denominator equal to 0, which vertical, a corner, right. So if I've got something, and this being, are the grades calculator or non-calculator? Non-calculator, right, yeah. So this being a non-calculator problem, where might I think that I would encounter a problem with differentiability here?
And solve.
And solve. So this would mean 1 equals e to the x. The only way to get e to the x to equal 1 is if x is 0. Which means in this case, x cannot be 0 for differentiability purposes. Anywhere else, I am good to go. That was easy. Look for places where the domain is not defined. Right. Yep. So you could write it all x except where x is 0. You could do negative infinity to 0, 0 to infinity. Any of those would work. That is cap.
That's not cap. On the end for the infinities, there's a bracket.
Can you actually be infinity?
Is it important?
You think you can be infinity? It's conceptual. You can't actually be infinity. Infinities are always parentheses. Did you forget that, Dylan? Always, yeah. Next question. Number 54.
What page number is 196?
196. I tried to pick out ones and kind of hit on the highlights here.
Yeah. All right, which one are we doing?
54. This is the one that y'all really don't like.
No. Well, we're doing it with her.
Yeah, we're doing it together. I haven't even told you what to do yet. What are you trying to do? Tell me what you're doing. Oh, you're looking in the book. I'm sorry. I apologize, Dylan. I was like, golly, what are you fixing to do with it? I just wrote an equation on the board.
Or do you plug in 0 now?
Okay, so let's think about what we're trying to find. We're trying to find if the function is continuous at x equals 0. What makes a function continuous?
No, you don't have your pencil. Don't let it equal to say from the right
Okay,
and the left.
that's right.
You don't
lift up your pencil, but let's be a little more calculus-y about it. So in order for it to be continuous at x equals 0, the limit as x approaches 0 from the left, yeah. Because if this is an FRQ, this is what you would have to show to get your points here. Equals the limit as x approaches 0 from the right, which also equals the actual function value at 0.
And then you would say, therefore,
f of x is continuous at x equals 0. So to find this, what I need to do is I need to find the limit from the left, I need to find the limit from the right, and then I need to find the function value at 0.
No.
It is a calculator problem. I don't know why.
No, it's gray. Gray is no calculator.
Oh, gray is no calculator? Oh, okay. I get so stinking confused.
What does it say? In the very beginning,
I am shocked that Noah Miller just said that.
hold on, let me find. Thank you for saying my name on the recording.
I'm sorry.
Noah Miller said something racist.
It was not racist.
Let me see here. Okay, I found it. Well, it says that if it's gray, then it's Noah is gay.
The limit as x approaches 0 from the left is what? So I'm using this equation, right? There's no asymptote or anything like that on sine. So the limit as I go to 0, I can just plug in.
Without a calculator.
Okay, so no calculator.
It's literally the beginning of the review.
So what this is really the limit as x approaches 0 of sine 2x. So what is the limit? And I can use substitution here because there's no asymptote or anything like that. It's the same as it comes in from the left and the right of sine. It's a solid point there. So I'm really using substitution. What's the sine of 0? What is the y value at 0? It is, in fact, 0.
All right, so what? All right, so that's the limit from the left.
Now let's do the limit from the right of f of x. So the limit as x goes to 0 of mx. So m is a constant here, right? And I'm talking about a line. So it's going to have another point here. The limit from the left and the right here is going to be the same. And when I'm talking about left and right, I'm talking about this particular function. It's just limits.
Oh, this is not the chapter. This is like chapter.
Yeah, but we're using it. Then we're going to talk about differentiability also. All right, so the limit as x goes to 0. Oh, bless you. Again, I can use substitution. So it'll just be 0, and that is what we were looking for. So now the question is f of 0 equal to 0? Well, I go, which equation corresponds there? The sine 2x. So the sine, is the sine of 0. We chose which equation matched if I'm plugging in 0. Bless you. And that's the first one because it's less than or equal to 0. F of 0. I have to show 3 things, remember. The limit from the left equals the limit from the right. And f of, that last step is ensuring that I do not have a hole. Because I could have some function that does this with a hole and plug the hole here. And the limit from the left and the right is the same, but the function value is not, and so it's not continuous.
So then you got to find where it equals that number. You got to plug it in and make sure it equals what you just got.
Right.
Because it's MX. Look at the equation.
I'm approaching 0, so I subbed in. And so therefore, that just is telling me which equation to use. This is telling me to come in from the right side. Coming in from the right side, I'm going to use this equation. This is greater than 0. Therefore, f of x is continuous at x equals 0. What? What? Some class of the week.
The class of the week's always some dumb class.
Okay, part B.
It's always like art or something.
Is it differentiable? Okay, can you be, let me ask you this.
No, it was just class. It was just.
If it's continuous, does that mean it's differentiable? Mm-mm. Why?
Wait, no.
This gets into the beginning of chapter 3. Okay, so how do I tell if it's a corner or a cusp thing? No calculator. So continuous is continuous, it's about the slopes at that point. The approaching slopes. So the left-hand derivative and the right-hand derivative. So does the derivative from the left at 0 equal the derivative of the right at 0?
No. Because one is an oscillating point, the other is a straight line.
Okay, well, what's the derivative of sine 2x?
Well, yeah. 2 cosine.
So then the derivative, so this is the d dx.
Maybe 1. Maybe 1.
Okay, so at 0 now, I would do 2 cosine 0. The cosine of 0 is 1 times 2 is 2. Now we need to plug it into the second equation. So we're checking to see if it's differentiable at that point. We know.
So you took differential.
Yes. So what's the derivative of mx at x equals 0? It's m. So the only time it would be, it is m. The only time it would be differentiable is if m equals 2.
Please explain what that is.
That's just saying evaluate it when x equals 0. So we would put it's only differentiable when x equals m. So if m was 0, yes, it would be differentiable there. But we don't know what m is right now, so.
Did you mean if m is 2?
2. I'm sorry, m is 2. We don't know what m is, so I would say it's only differentiable when m equals 2. The question would more likely ask you, what value would you need for m in order for the function to be differentiable at the point x equals 0? 2. No. Why is m 1? M is unknown, but it's a constant. So the derivative of mx would be m.
If you plug in, okay, so the derivative of mx is m. And so we don't know what m is. It was like, ooh.
Right. Because mx is a line, right? It's got a constant slope. So no matter where you go, the derivative is the same on there. It's always m. So I need this constant slope to be the same thing as the slope here in order for it to be differentiable. Right, it's not. Well, unless m is 2, m's not defined. Correct. Right.
So why does it say what is it differentiable at x equals 0?
So and explain.
I know, but like we need to know what m is.
If m is 2, then yes, it's differentiable at x equals 0. Any other value, it would not be differentiable.
So a is yes, no, it's not.
And if you think about it, it makes sense because
it's yes at m equals 2.
It's not the root of separate.
here's my sine 2x graph, and then I come in at the same point, and they share this point, but depending on what the slope of that line is, depends on if it's differentiable or not, right? If I come in with the exact same slope here and continue on, yeah, it'd be differentiable. But But it is continuous, we know that. But what if it does that? That's not differentiable. It's corner, right?
What does differential mean? I forgot.
The slope differentiable means from the left and the right as you come in, the slopes are the same.
Of the tangent.
Of the tangents, that's right, because
Yeah.
that's what derivative is.
Of the regular, it's the.
These are those thought-provoking questions, and these are the kind of questions they love because it tests to see, do you really not just memorize the definition of a derivative, but do you understand what it means to be differentiable? So I would say differentiable when x equals 0 only when m equals 2. Oh. Oh, that's what I would do here. I would say I would probably, we don't really have notation for left hand and right hand derivative like that. So I would probably, unless you get into the difference question where you would go the limit as h goes to 0 from the left and we're not really using that. So I would just come here and say left hand and maybe right hand here and label it that way so they know. But the fact that you know that you're finding the derivative of both of them is what they want to see. Other questions about that one? No, I'll tell you for them. This?
Yeah, like the questions we're doing.
Oh. They're not necessarily, I think everything, I tried to pick the harder ones. The straightforward ones are, yeah. All right, let's look at 68.
I don't know, 69 is a way better number.
Shut up.
You did.
Shut up.
What is 69?
Find the value of dw ds at s equals 0 if w equals the sine of the square root of r minus 2
It is. It actually is.
Chase Young is a football player. His name is Chase Young, so maybe.
I just now got that. What the heck?
All right, this kind of tests your knowledge of the chain rule here.
There's no way there's going to be this hard a question on
If there is none.
Notice this is the function composition kind of question. Okay, this is the one that tests this is like the u, yes. This is f and this is u. And we're asked to find the derivative of w with respect to r. Okay? I mean with respect to x. S. Here.
So whenever we take the derivative of w, we're going to have to do
I'll tell you what you got to do. On that first one, you got to plug in the whole equation for r. Right?
I've wiped my nose on my ghost plate for them.
What? So you could do that. If you're plug-in people, you can do that. Is that what y'all did on the quiz? Did you plug in? Okay, we can plug in. If I plug in, that's saying that w is the sine of the square root. That's what I would do. I would find the derivative of each one and then.
Let's do that then. It's still plugging in.
Here's what I would do in this situation. Let me just tell you what I would do in this. would do dWds on this one. So I would find the derivative of w with respect to x, which means any other variable in here, I'm going to follow with dr ds. Okay? Kind of like whenever I do, if I'm taking the derivative and there's x's and y's, because I'm doing it with respect to x, if I take the derivative of y, I have to follow it with dy dx, right?
But in this case,
In this case, if I'm finding dw ds, then any other variable that I find the derivative of within this equation, I'm going to follow with d, whatever that variable is, ds, if it's not an s. Okay? So, the derivative of sine is cosine times the square root of r minus 2, because y'all are good at that.
D over D is nuts. Oh, yeah. Wait, yeah. Miss Allison Gordon is right. dr over ds. All right, let's go. Next
Right?
paragraph.
Look, and here is why. I'm finding it with respect to s. Are y'all okay there?
Wait, so dr dx,
Okay.
okay.
I need dr ds. Do you agree?
Yeah. How about DWGS? It's still there.
Well, I'm going to keep it here, but I'm going to find out, well, what is this? Because I need a value. That's the derivative of this one. So dr ds is going to be 8 cosine.
Oh, now so you find that.
Over 6.
You find that and then plug it in right there. Right? You gotta do the inside. Oh, then you gotta do
But the-
WDS.
No.
Oh, no, you don't.
But I'm with respect to s, so I'm good with this just being a 1. I don't have to do dsds. dsds is 1. Okay, so now this, now remember, I want all the same variable in here, so I'm also going to replace r with this. Okay, and remember, I'm also evaluating when s equals 0. Let's plug it in first, then let's replace the s's with 0. So you see. It's
more weird.
It's more clear than
oh, there's another r.
my dream is
It's a lot to write. You don't have to. I would plug in 0 for s in this before I did all this, but just for the sake of example, so you can see where everything is coming from.
You know those stickers that go on apples and bananas? I want to be the person that puts those on them. That's what I want to do.
Is that 2 negative signs?
No. I just realized I didn't know.
Hold on, wait.
Wait. Okay.
Yeah, you did. Because
No.
you're plugging that in. Oh, wait. No, you didn't.
I replaced each r with what r is. And then I replaced drds with what I know drds is. Now I'm going to take each s and I'm going to make it 0. 0. 0.
Do it again, Emma. Now I got them.
Ha ha ha.
Man, you're ready to laugh.
How come I understand this more than anything else?
No, you don't. This is hard.
This is good, but I understand it more than everything else. I haven't touched my phone. Yeah, I haven't touched my phone once today.
Did you put it on my desk today?
Actually, this is my bag.
But still. All right. Cosine of the square root of 8 sine pi over 6 minus 2. Oh, you're right.
Wait, what are you doing? Well, you had to plug in 0 for F, so you got to show that. Wait.
You say yay. No.
Yes.
These are unit circle values. Pi over 6. What are the coordinates? If you can think of the coordinates, it'll make this easier.
Wait.
It's 30 degrees, so it's the very first one.
I'm looking at it right here. It's square root 3 over 2.
I was going to say that's the longer.
Yeah, I'm square root 3. It's like hard to say that.
So here's the way I think about it. I know square root of 3 over 2 is bigger than 1 over 2, right? I know 30 degrees is the first click that I get to. So that has a bigger x value than it does y value. That helps me keep straight which one goes first. Some people can just close their eyes and know what the coordinates are there. Or some people can just go, oh, the cosine of pi over 6. Whoa. I can't do that. I have to really think about it. But okay. Once you have that coordinate there, it's downhill from here, right? We hope. Cosine of it goes pi over 6, pi over 4, pi over 3. We did the sine value here inside. That's fine.
Well, I guess that does explain it a little. Wait, you didn't need to put that cosine.
Something went
You
wrong.
didn't need to have that cosine right there. Right? Huh?
I don't have to have the cosine there.
No, it's cosine at the second one. So 8 times 1/2 is 4. Square root of 4. 2. 2 minus 2 is 0. And it's also it would be easier if you put the second one.
No.
2 and put the
What?
square root and then it.
No, because the minus 2 is not in the parentheses.
This does go. This is under the, yeah.
It's in the parentheses,
It's not, but right. So it's like this. So it's right. So it's the cosine of 0. Cosine of 0 is 1, yes. All right, times. Let's work with this middle piece. 1/2 times 4 to the negative 1/2. 1/2 times 1/2, which is 1/4. I'm just working piece by piece.
What about that first thing then, the 1/2 times 4?
Half of 8 is 4 to the negative 1/2. That flips it down to the bottom and becomes a square root. So this is 1 over the square root of 4.
But when did you do the 1/2 times 1/2 though?
Do what?
When did you do the 1/2 times 1/2?
I just combined that step. It would have been easier what? If I done what? If we plugged in earlier? Oh, and then canceled them.
What missed we do? When did you do when did you do 1/2 times 1/2 though? You did 1/2 times 8, but when did you do 1/2 times 1/2? Not right there in the first part.
Where?
There's a 1/2 right there. You have to distribute.
You don't distribute when there's multiply.
Oh, okay. When did you do the 1/2 though? Like, did you have to raise the 1/2?
Well, 4 to the negative 1/2 I did first, which is 1 over the square root of 4, which is 1/2.
And what about 1/2?
So 1/2 times 1/2 gave me the 1/4.
You didn't have to raise that 1/2 to the negative 1/2?
No, because the negative 1/2 being no, this only goes to the 4 because of order of operations.
I know this is on the whole parentheses. Wouldn't you have both?
So I did inside parentheses first, and I got 4. I told you, you'll get caught up on the small stuff every time.
Yeah, you gotta expect, we have limitations. We just spent 15 to 20 minutes on this problem. How are we gonna do it in 3 minutes? I'm just saying, like, you might ready.
No, like that was a fun one.
I like it.
Well, you must.
No offense.
What's the particle's initial position at t equals 0?
All you gotta do is find the derivative.
Initial position
Oh.
at t equals 0. That tells me where I'm starting.
So the cosine of pi over 4 is times 10. I was thinking
This is B. We skip A. A is
5
about
times the square root of 2. Oh my gosh, it's wonderful.
wonderful. What? Oh, that was just one part. What points reached by the particle are the farthest to the left and right of us?
Stop. Could you zoom out a little bit? Go.
I go there.
Oh, wait. So cosine. Cosine can only go up to 1.
Correct. Well, what you're wanting, so let's think about this. The farthest left, so we want maximum
No.
and minimum,
No. That would be
right?
up and down, not left and right. You're wrong. How? No.
Yes.
Wait, what? No, what if the left and right is not?
That's what I would say. That's what I would do on this one. For this one, I would think, okay, the furthest left and the furthest right from the origin. Okay, let's think about it. We're talking about position, so we want, the position is where it is, so we want the biggest positive number and the smallest negative number. But then it's times 10. But then if you plug that in, you're plugging in a t value, but you're looking at a y value. You see what I'm saying? But that's what you're giving me. If you give me 1 and -1 on cosine, you're giving me the maximum y values there, right? You see what I'm saying? That's not the t. And so you can't plug it in for t. So I want the biggest, so let me ask you that first. What's the biggest value that the position can take on?
Infinity. 0.
And so we're answering C, right?
We're answering C right now. What points reached by the particle are the farthest to the left and the right of the origin?
-5 pi, no, -5 square root 2 conjugate.
I thought we were still on.
That's where it starts. Okay, so I'm not at, here's the origin. So I start, this is where I begin. And then which way does it move?
It starts to the left.
How do I know?
To the right though. It says that t is greater than 0. Or sorry, it says that it says t is greater than 3.
But yeah, because that's time.
I know. So I mean, you think it'd be going the other way.
Time doesn't go backwards. Right. But this is measuring position as a function of time. You're not. I'm asking you questions that are making you think about it.
What if you just plug in a number that's above 0?
Okay, so you can
And it's always
just
above
see,
t, then,
but is it always going to, this is a cosine curve, so what Allison was saying is right. It's
But it'll still be going right or left.
yeah.
Yeah. So then,
But when is it going right and when is it going left?
When it's positive.
What's positive? When does it change direction? What about velocity?
When the velocity slopes.
you know what? You're trying to freak us up. This
When
question
the
is
velocity.
This question is David. Okay. And it may or may not change position there, right?
Oh wait, no. When velocity is 0, that's where
When
it
velocity changes, right?
Yeah, that's where it changes.
I'm sorry, I didn't hear you.
Yeah, that's where it changes. Yeah. Yes. Yes.
Where's your sheet? Do you have the sheet I gave y'all? Remember the little cheat sheet that I said keep up with?
No, I'm telling you, when velocity is 0, that's where it changes. Direction.
It slows down. It could change.
And now you're getting into speed.
Speed, just absolute.
I said don't have zeros.
Particle motion is a part of every chapter.
Okay. When you see it,
The reason it's a part of this chapter is whenever we take derivative, we end up chain ruling, and chain rule comes back in here. Particle motion never got. Particle motion is a guaranteed FRQ. What do we do?
okay, so I got the sheet.
Don't look at the solutions. Try to figure it out on your own first. That's why I'm not just telling you what to do. I want you to think about it.
We have been, we thumped already.